In this video, we discuss a power series. Let's see what a power series is. A series like of the form sigma of a constant coefficients ck. X is a variable, then to the power of k, where k runs from 0 to infinity, or k can run from 1 to infinity, or k can run from any positive integer to infinity, is a power series. As you see, here a variable is involved. So the general term of the power series has a variable, in this case, the variable x. CKs are constants, are given constants. More generally, a power series is of the form. Here we just had x to the power of k. In the more general sense, it might be like ck times x minus some constant a to the power of k, and k runs from 0 to infinity. Okay, so let's see some examples. Consider the power series sigma 1 over 2 to the power of k times x to the k, and k runs, it could be from 0 or from 1 up to infinity. This is a power series. By the way, this series could have been given so the same as sigma of x over 2 to the power of k. So these two are the same series, of course. So here, one question that arises here, since we have a variable, the question is, for what values of x does the power series converge? And those values of x, they form an interval, and that's called the interval of convergence. So let me ask this question. So that's part one for this example. For what values of x does this power series converge? So these values of x, they form an interval, and that's called the interval of convergence. So in fact, the more common terminology that we use is find the interval of convergence. So let's use the root test that we discussed in the previous meeting. And if the limit of the kth root of the kth term, the kth term is here, right? If the limit of this 1 over 2k, as you know, we need an absolute value sign as k tends to infinity. If this is less than 1, then the series is convergence. The series is convergent. The series, or this power series, is convergent. And from there, we can find which values of x make this power series convergent. So we use the root test. Let me write it here. Okay, now let's work with this inequality. Let me repeat that on the next page. So the limit as k tends to infinity of the kth root of 1 over absolute value of 1 over 2 to the power of k, x to the power of k, this must be less than 1. But in this example, k easily cancels out because we have k as the index of the radical, and also k is the exponent of 2 and x. Therefore, we have the limit as k tends to infinity of absolute value of 1/2 times x. This should be less than 1. There is no k anymore. K canceled out. So that was based on basic algebra. So we don't need to keep the limit sign anymore. Therefore, if 1/2 times x is less than 1, then the series is convergent. So this means which x's? Let's multiply both sides by 2. If we do that, absolute value of x is less than 2. What interval is this? Absolute value of x is less than 2 is x between -2 and +2. So for these x's, that given series is convergent. If x is 2, we will have sigma of 1s, which is obviously divergent. And if x is -2, again, that series become divergent. And definitely for more than 2 or less than -2, the series is divergent. So for these x's, the series is convergent. For these x's, x more than -2 and x less than 2. Therefore, the interval of convergence is the open interval from -2 to +2. As I explained, -2 and 2 cannot be included because if you replace x by -2 or by 2, you will see that you can easily see that the series will be divergent. So for these x's in this interval, we get a convergent power series, and this is the interval of convergence. In such problems, usually we have one part about what is the radius of convergence. So in fact, this is a kind of simple question because what was the interval of convergence from the previous part one? The interval of convergence was from -2 to 2. Now, what is the radius of this interval? Meaning that from the center of this interval, the center of this interval is 0. So if I look at this interval on the real line, suppose this is the real line, -2 here, +2 here. The center of this interval is 0. And the radius of this interval is equal to 2. Because the distance from the center of that interval to the end points of this interval is 2. So the interval itself was this interval between -2 and +2. The center of this interval was 0, and the radius, meaning that the distance from the center of the interval to the endpoints of this interval is 2. So the radius of interval is 2. The radius of convergence is equal to 2. The letter that is common to use is capital R. So R is 2. Let's do another example. So consider this the power series sigma 4x raised to the power of k, and k runs. As I mentioned, it could run from 0 or could run from 1 or any other positive integer up to infinity. Part 1, find the interval of convergence. And for to do this, obviously, as we did for the previous example, we use the root test. I would suggest that you try this on your own before watching my solution. So we use the root test. We discussed the root test in the previous example. So the limits as k tends to infinity of the general term, this is our general term ak, the limit of the kth root of the general term, which is 4x to the power of k. If it is less than 1, we definitely know that the series is convergent. But here it has x, so we need to solve an inequality. Here, the k's easily cancel out because we have one k as the index of the radical, the other k is the power of 4x. And so we have the limit as k tends to infinity, 4x is less than 1. There is no k here, therefore there is no need to this limit sign. We just have x, no k. And as I have mentioned before, here we needed an absolute value as well, as you might remember in the root test, we need to have the limit as k tends to infinity of the kth root of the absolute value of the kth term. So that's why we need absolute value here. This is less than 1, meaning that if I divide both sides by 4, absolute value of x is less than 1/4. What does that mean? That means that if absolute value of x is less than 1/4, x is between these two values, minus 1/4 and plus 1/4. You have seen this in more elementary courses that if absolute value of the variable is less than a positive number, x is between minus that number and plus that number. So therefore, the interval of convergence is this open interval. At the endpoints, you can easily see that, for instance, at 1/4, if I replace x with 1/4 in the original series, I'll get a divergent series as well as with minus 1/4. So for this example, the interval of convergence is obviously an open interval. What is the radius of radius of convergence? As I explained on the previous example, here the interval of convergence is this interval, all the x's more than minus 1/4 and less than 1/4. The center of this interval is 0. So the radius is what? The distance from the center to the end point of this interval, r is 1/4. So this radius of convergence, which is the radius of the interval of convergence, is 1/4.